Alright, the purpose of this video is to show you guys how to do program 9.11 out of the textbook Introduction to Java, the comprehensive version 10th edition by Daniel Liang. And what we're going to do is basically just follow the directions in this program instructions here and just build ourselves a program in Java. So first thing you need to do is open up NetBeans. And when you get there, do File, New Project, and just choose the options that are default here. Wow, you'd think it would be faster. Might have to do some editing on this video. Once we have that, we can click on Finish, and we should have ourselves a blank project to start off with. And we're going to make two classes. One class is already made for us, whatever it is we named when we started off our project. And the other class is going to be called LinearEquation. So we're going to design this class called LinearEquation. So let's just go step by step and create this class. First thing it says is create private data fields A, B, C, D, E, and F. So let's go ahead and start there. To create a class, all we do is we go outside of this class. We have to go after the end of it and just type class, and the class name will be LinearEquation. And it's got private data fields A, B, C, D, E, and F. So we literally just say private, and I believe they're integers. You know what? They don't have to be integers. They can be doubles. And we'll have A, now we want to make a constructor with the arguments for this. So do we want a no-args constructor? No, we want to get an args, whatever you want to call it, an args constructor. So how do we create a constructor? We use the same name as the class, and I misspelled it. How about that? It should be LinearEquation. And that is, if we didn't put any args, it would be like this. But we are going to put arguments. What do these have to be? Doubles, right? So we got to put double A, double B, double C, and so on and so forth. I'm just going to use my old friend, copy and paste. And I'll change this to B, C, D, E, and I believe we had F also. The last one does not have a comma after it. Okay, so now we've done number 1 and number 2 here. And so now how do we assign values to the when we construct this, we want these variables to be set to this. So if we're using the same name, that's going to be an issue. We got to use different names, right? Let's put a, let me just pause this real quick here. Let's resume this. So what I'm going to do is, just for the sake of making this simple, let's put ones in front of all these, or after all these. So these are the variables that are given into the constructor, and then we're going to assign the values that are in the private ones, whatever it is that was passed to the function, to the class, whatever, when you initialized it. So let's just do this. Let's just say A gets A1. Do you see that? Yeah.
You could have them the same name, and then you just do this dot A gets A.
You want to do that? Let's do that. I like it, Neil. I'm not sure what's easier to understand, but if we say this dot A, have we gone over that yet? Maybe we have. I'm not sure we have. This dot A gets A means it's the instance of the object that we created. Gets the variable, right? So that this applies to the object that's been created. So either way will work. Either way is going to be work. Is going to work, but probably this is more Java-ish. And personally, I like to put these all on one line because they're all the same. But if you want to make them all separate lines, be my guest. I don't like to have lots of lines of code. To me, I don't win anything by that. I guess it makes it look like you coded more if you have more lines of code. Oh, sorry, F. So what this does is when we create a new linear equation, those data fields are going to be set by whatever we pass to it. So up here, so this is a class, and this is a class. We're going to create a new instance of this class in our main function up here. So how would we create this particular object? We might want to create a variable for it. We can say linear equation, and then we'll call it L. LE we'll call it. Gets new linear equation, and then we can give it a bunch of values, and they have to be doubles. And that's how we'll instantiate this particular class. So let's just pick, I'll just pick one. It takes 6 of them, right? 1, 2, 3, 4, 5, 6. Take 6 of them. So 1, 2, 3, 4, 5, 6, and we can put whatever we want. So do you see how that's being instantiated? So if we were to run this program right now, all it would do would be create this new object, and it just has these variables assigned, but it doesn't print anything out. So here we go. We now have the private data fields, and we also have the constructor with those arguments. Now we need 6 getter methods. Let's create a getter method. So we're here. To create a method, we're going to have. I think we'll make it public. It has to be public. Why does it have to be public? So it's available to other classes, right? A public method is available to other classes, and a private one is only available inside the class. So public, and then I'm not sure it has to be static. Public, and then we'll call it, is it going to return something? Yes. It's going to return a double, right? The getter methods always return something, and we'll call this get A. Does it take any parameters? No, because we're just getting a value, right? And then what do? Return A. That's it.
And we do it for the rest.
That's it. Copy and paste. Oh, man. Got to figure out a fast way to not have to deal with this. So B, C, D, E. It's customary to capitalize the second word in these functions, so that's why I'm doing that. But probably some people wouldn't. All right. So now I'm going to go back to my instruction that says we need 6 getter methods. Okay, done. Now it says create a method called isSolvable that returns true if AD minus BC is not 0. So anybody want to take a stab at this one? Public?
Create a public Boolean
Public Boolean
is solvable. Can you see the Adobe
Is solvable.
document again?
Yep.
See the Adobe document, thank you. And it looks like we need arguments for A, B, C, and D.
That's right. We're going to need arguments for A, B, C, and D. So if I'm clever, I can just copy these bad boys, right?
Yep.
Or I could just use them because they are available to us, right? We don't need them to be passed.
Yeah, that's...
Because when we created it, we should have it there.
Yeah, we can do that. No arguments.
So we don't really need any arguments because we have access to the things we need. You're on a roll there, Austin. You want to take another one?
So, an if statement,
Can do that.
A times D minus B times C, but I would prefer putting the B times C and the A times D in parentheses to prevent order of operations from being compromised. And then after the
We'll
B
risk it.
times C equals 0, double equals,
Yep.
and then and this returns true if this is true, so then we would put in return true.
Yes.
Shouldn't you just do return and then just that, like, that equation inside of it?
This identity right here?
Yeah, just throw that inside the return.
We absolutely can.
Because it's just, that's all, it returns that if that's true.
Right. So we can say if this here is true, if it equals 0, the problem is if it equals 0, it's not solvable. So we probably want to return. Right. Exactly. Return not this. But here we say return false, right? And then here we'd say else. Return true. But we can to make ourselves, if we're clever, like Brady's got an idea there and I like it, is we could just say return not this. And we might as well do it that way because that's what you're going to see in the class anyway. So you see how clever that's. I mean, there's a lot more thinking going on involved in that, but it's less lines of code. So if A times D minus B times C does in fact equal 0, what's it going to return?
If it does not,
If it does,
then it
returns false. If it's not, it returns not false, which is true. Now this might be worth commenting if it's too complicated, right? We could say returns false if this equals 0. So basically, so it returns false if not solvable, which is what you want. This is one of those cases, remember I was telling you where in real life you really want to comment the things that are a little tricky? This is one of those things that's a little tricky for this level of coder, so it's a good idea to put a little note in there. Okay, so now we have a method, we have 6 getter methods, and we have this isSolvable method. Nicely done, Austin and Brady. Now we got to put 2 more methods in, and boom, we're almost done. GetX and getY that return the solution. These are the equations for the solution. So, who wants to take a stab at how to do getX? Can you remember these? Or should I type them in? Now let's just do it. So we're going to do getX. Let's do public getX. Do I need any arguments to this? It does return something. It returns a double. Do I need any arguments? No, we don't need any, right? Because we got all the values we need. GetX basically gives us, some combination of A, B, C, D, E, and F, which we already have that set, right? Let me construct it. So all we got to do is give them this equation. So ED minus BF. So we can say E times D minus E times D minus B times F. That's one quantity, right? And then we're going to divide that by ADBC. A times D minus B times C. You can't just put ADBC in there because it'll think it's a variable name. You have to put this, this is how you write it. So now that's going to be, we just return that. And then we have, that's what X is. To do Y, pretty much the same bailiwick. Get Y is AFEC. It's AFEC, and then AD minus BC, the same as up here. I love when I can copy and paste. So those are the solutions. So now we've created this entire class. Now all we have to do is test it. So if we have a system of linear equations, AX plus BY equals E and CX plus DY equals F, then we should be able to use this to get it. So let's suppose we had, does everybody follow this so far? All right, good. So now let's try getting some good values here. Let's suppose that we had A is 1, B is 1, and E is 1, right? And let's try C is 1, D is minus 1, and F is 1. So all of them are 1s except for D is a minus 1. You want to try to solve that? So basically everything is 1 except for d is a minus 1. So let's go up here and let's create everything is 1 except for d. So A, B, C, A, B, C. D is going to be minus 1. The other ones are 1. And let's see if that one flies. So we're going to say system dot out dot print line, and we'll say x plus getX, right? It would be le dot getX plus space y plus le dot get y. Bip bip, bing bang boom. All right, beautiful. And it's not correct. What am I missing here? Cannot find symbol. Class system identifier expected. Where is this?
I did the same thing and it works for me. Oh, I see it. The closing bracket. You do it right after the closing bracket for the main class.
Yeah, you're out of
The
the main
public
class
static
right now.
void.
Oh, thank you.
It's not in there.
Get it right, Georgie. Thank you. There we go. All right. So now this should print out what x and y. Whoa! What's this? Non-static variable cannot be referenced from static content. You guys know static? This is a good little thing here. It says non-static variable cannot be referenced from static content.
Even though it works for me.
You don't have static in any of these?
I don't have static in any of these, and it works.
You don't have static here?
In the private part,
Yeah, do you?
private double. No, I don't have that.
It seems that I have everything the same too. It's not even here.
Okay.
Based on the top, it's like, but
This is public static void. This is good. Oh, this class, this one's got to be closed here. No, that's not. How did that happen?
there we go.
But this class, did I not close my class up? Okay.
You probably put it within the public class.
So I got an odd error, but it had nothing to do with what was actually the problem. All right, let's see what happens. I just ran it using clicking this thing. X is 1, Y is 0. Perfect. That's what we're supposed to get. Right? Now we could try some other linear equations, right? And test them to make sure that we feel comfortable with them. But that's basically it. So any questions about how to do this, set up a class like this? All right, good. Now what we want to do is let's draw the diagram. So what I do is I use draw.io. If you go to draw.io, you can. I use my Google Drive, but you can do whatever you want to do to create to create diagrams, and they save to my Google Drive. I love it. So I'm going to create a new diagram, and I'm going to create it using software design diagrams, because we're doing software design, right? And then I'm going to go down to the very bottom, and I'm going to choose the lower left gives me a UML class diagram. Don't worry about the arrows for at this point. Just worry about the whatever you want to call them, the classes. So you can delete all the unnecessary. We only have 2 classes in our diagram. We only have 2 classes in our particular program. Sorry, in our program. So what do we have what do we record in these class diagrams? We put the class name, we put the data fields, and we put the methods. That's all we do. So let's take the first class, this one here. How many data fields are in there? Sorry. How many data fields are in this class? Close. Not 1. 0, right? There's no data fields in this class. You only count the class level ones. You don't count the variables that are in here. This is not a class property. Class data field. So yeah, it is obviously a declared place in memory, but no, it's just the ones at this level. So in this particular diagram, we would have Java application 1, and then we have nothing in this section because there's no data fields in there. How about methods? What methods do I have inside this class? Just got one. Sometimes people don't put main in there, but we will. It's main, and what's the what kind of arguments does it take? Right, string, and then I put a space in between these brackets because they're hard to read otherwise. Args. And then what is the output? Void. So done. That wasn't too miserable. That right there is the class diagram for our Java application 1 class. Okay, not bad. Now I'm going to rename this thing file. Rename, where are you? Rename. And I'm going to call this program 0911 because that's the one. I'm going to save all these for future classes. Okay, so now we have the second class. It's a little bit more lengthy. This class, and it's called LinearEquation. So we put the class LinearEquation here. How many data fields does it have? 6 of them, right. So I'm just going to copy this and paste it again. Whoa. I guess that doesn't work. Come on. This is still okay, right? I guess I have to go by hand? So I have 6 of them, and what is the name? What are their names? A, B, C, D, E, right? And F. So we have A. Oh, sorry, yeah, A, and it is what kind of variable? What's the data type? Double. I can't believe. And the little minus sign in front of it means it's private. The little plus sign in front of that means it's public. So that's it. A, B. I don't know why I can't copy and paste this. Seems like I ought to. Yeah, good. A, B, C. We could have probably put commas there, but D, E, F. So this is LinearEquation. Save that. Okay, so now we have to put the methods in there. How many methods do we have? We have 6 getter methods. We have isSolvable, getX, and getY. So we got 9 total methods in there. 1, 2, 3, 4, 5, 6, 7, 8. We'll make one more. So what's the first method? Get A. Does it take any...
Double.
Huh?
Returns double.
It takes no arguments and it returns a double. It seems to me we ought to be able to be smart and just copy and paste this. Copy, paste. Six of them. Huh? A. We don't want 9 of them. B, C, D, E, F. And then this one's going to be isSolvable, right? And it returns a Boolean. And then we got 2 more, right? We got
If X is double, if Y is double.
X. And that's all of these, right? Now sometimes you won't put the getters and setters in there or the constructors just for brevity because everybody knows you have to have them. But for this course, you are going to put them every single time. So we also want to put the constructor in there. Is a constructor public? It doesn't really get declared public, right? You just put it in like this. But we definitely need to have all of these in there. You see that? All right. So now we got both classes have been documented using UML class diagrams. There's a lot of UML diagrams, but this is just a UML class diagram. Any questions so far about that? Okay, so now all we have to do is comment our code and we're done. Let's go and do that. We will go to... On the CSIS server, I created a file called comments.txt. You can use this file as a template if you need to. But let's do this properly here. We'll do this. I'm going to copy it and I'm going to paste it into my code in NetBeans. So for this course, we want to have comments at the top like this before the package, the very beginning of the code.
If you put it on the CSIS server, you can't put the package in there.
You don't want the package in there for CSIS server, but I'll show you that actually after this. We'll put it all in CSIS server. But so I'm going to change this to look like this, and you may have to Shift Tab will we'll move it over there. I'm not sure why it doesn't work in the indentation is not consistent between Notepad++ and this editor. Who knows? Oh crap. Wow. don't know if we even need all this. So what does this program do? The description we do. So the file name, the class, the file name is, this one's going to be Java Application 1. But it could have been anything. It could have been Program 0901 or whatever you want it to be. Author, your SVSU ID, the course, what section you're in. This one's Monday, Wednesday. And then the semester. This makes it easier to you know, if you have a whole bunch of papers, you can figure out where it belongs. Then this description is really important. What does the program do? Can anybody figure out a good way to describe this program? What does it do? The program returns the solution to a linear equation. Right? And it's supposed to return or not solvable if a linear if not solvable. Just that's good enough, if not solvable. Now, before we finish up these comments, does this thing return not solvable? If we put in here, let's suppose I put in here, here I'm going to copy this, and I'm going to paste a not solvable linear equation. Of course, it's completely not solvable if both equations are the same, right? You have to have two equations and two unknowns to solve a two equation linear system of equations, right? But if they're the same equation, you're going to have an infinite number of values. So this next one should return not solvable. So here we should really say if solvable, right?
Can you change the second one?
What's this say?
You have an error. You have to.
Oh, yeah, right. I'll call this LE1 and LE2. And I'll call it LE and LE2. Ah, Judy. Okay. So what I really need to say is if LE2 is solvable, right? Then print the solution, right? If it's solvable, then we can print this, right? Otherwise, what do we print if it's not solvable? Let me see what it says. It says, program prompts the user to enter these things. Oh, geez. And put, if 80, for the equation has no solution. So this is what we're supposed to type if it does not have a solution. That's what we're supposed to type. So here I'm going to put in my comments. So I would have forgot that. So this thing also says we're supposed to have the user enter in all those things, which we'll get to in a second. So are we comfortable in these comments? You're going to love this part of it. What is the processing of this program? What's the processing of it? The processing should be whatever it is in the main method. That's what it should be. So the specifications say have the user enter in, right? Test program that prompts the user to enter that in and display the results. So we don't have that, right? So we need to put that in there. So the first thing we've got to do is say, well, we'll prompt the user. And we're going to say enter 6 numbers, right? So we've prompted the user to say, hey, enter 6 numbers. And then we
have to have a scanner.
we got to have a scanner. So we have to have scanner SC gets new scanner. And we're going to say system.in. This will work for our keyboard here in
We need to import the
in NetBeans. We will. Luckily, we have this little red dot that will make us import it, which is a beautiful thing. But this will still work in CSAS server when we do it in PuTTY. It'll still work when we use submit_j. So in submit_j, we'll just have 6 numbers in there. Now, if I want to assign values to these here, see here we don't really need this anymore. We have this one right here. So if the linear equation, if it's solvable, it prints it out. If it's not solvable, it says the equation has no solution. So now the question is, how do we get these numbers in there? Any ideas?
Use a loop and then put it into well, you could either put it all into a one-dimensional array that has no really defined.
There's a lot of ways to do it. We could just put next int in there, but we could create variables for it. We could create an array for it. Doesn't really matter. But we're going to need doubles, so not ints. So let's just create some an array A. Let's call the array I don't know what we want to call it. Z. An array of doubles, and let's just put them in there. How about that? The other thing we could do, I think, if the person enters in 6 of them in a row, we might be able to use next int that way. So let's do that. So let's do double. We'll call it the array Z. Gets new double 6, right? Oops. And I guess we can pop this in a loop. So basically, while we'll just loop through all of the elements of the array and just keep on assigning things until it's done. So let's say enter. Going to be system.out this.
Number plus I. Number plus I.
We could say enter number and then say plus, and then have we could even have number, and then we'll put this in here, and then put I, and then plus. Like that, if we want to be fancy about it.
Well, you already had enter 6 numbers up top, so.
Well, it'll say enter 6 numbers. It'll say enter number 1, enter number 2, enter number 3. And so here we'll say Z of I gets next SC dot next double, right? Can we live with that? So we have a prompt and a scanner, and then we create this little array here, and we populate it with whatever they enter in. And then here we no longer have 1, 1, 1, 1, 1. We have Z of 0, and then we have all the other ones, all the elements that go in there. So 0, 1, 2, 3, 4, 5. That's 6 of them. Z5 is my last one. So can we live with that? So we can comment this a little bit better, but so we need to now print these values. Let's go and sorry, we need to enter them in. So 1, let's say, I'm just going to say 1, 1, 1, and then I'm going to say 1 minus 1. Whoops. Just get it right. We can do all kinds of error checking, but 1, 1, 1. That's ABC, right? Then D is minus 1, right? And then 1, 1. And that's correct. It's the same thing we got before. But now if I type in all ones, 1, 1, 1, 1, 1, 1, it has no solution because they're typing the same equation in twice, right? If x plus y equals 1 and x plus y equals 1, you have basically the same equation, and you have two unknowns. You can't. Everything, there's no way to know. There's a whole system of answers. There's not any solutions for x and y. So this works. But the point that I was making about the comments is, whatever's going on in your main method, that's what should be inside of this processing comments. So let's write it up. So here, the first thing we do is get 6 numbers from user or input file. And I'll put or input file. And so here we've created all this. We don't need all that. And now we've got the numbers. So this is step 1. Get the numbers from the input file. That's really how much comments you need. Not to comment every single line, but basic chunks of code. This is what I call the section level code, section level comments. Then here it is print solution or the equation has no solution. Right? That's it. So when I go to the comments up here, I can just use these as my steps for the comments. So here, processing, program does the following, this, and this. That's perfectly fine commented code. Might be a little bit easier if you indent it a little, but that's fine. The output is a solution. The precondition, there's none. We could put none. We could say here, if using submit J, input.data must be in the same directory as the thing, right? Must be in the same directory as executable code. That's a precondition. The postcondition, the solution or message is printed on the screen. That's it. Now we could do preconditions and postconditions of every one of these methods, but let's not get into that right now. This is enough. If you do this, you're demonstrating to me that you understand the concept. So now we've done the code, we've done the comments, we did the diagrams, and it works. Done. Now all we got to do left is to show how to do this on Submit J, and Bob's your uncle, right? So this one is program 911, processing, description. I'll even put in here, oops, this is program 9.11 from page 353, sorry, from page 363, from page 363 of textbook. Save that. I'm just going to copy the whole thing, and I'm going to go into Notepad, and I'll go into CS 116, and I will do create new file, and it's going to be called program, I could call it Java application 1, but I'm not, program 0911.java. And to make it work, I got to go all the way down and open it up. To make it work, I paste everything in here just exactly the same way as I did before, and this time I'm going to call it program 0911.java, and I'm going to have to get rid of the package, and I'm going to change this to be program 09. There. Now this should fly. And I want to get input. I want to use input.data, so I also have to create an input.data file. Where did I save this? Up top? Yeah, I did. I saved it up here. So I need to create an input.data file, so let's do that. Create new file. Input. I think I might call it 0911.data. I'll even call one of them A and one of them B. Open it. And I'm going to put here 111, and then D is -1, and then 11. And that should give us one set. I'll do file save as, and I'll do B, because you usually want to test both branches of your code, or all branches. I'm going to have all B1s. And now I've got two input files in here that I can run.
You may want to give them one directory.
I'll create a whole subdirectory, yeah. As a matter of fact, yeah, I can do that. We'll call this program 0909. So I'm going to create a new directory. Program 0911. It's my new directory. And do I have to refresh that? Oh yeah, I see it. Sorry. Oh yeah, and I got to, did I just screw myself? I need to take those files and drag and drop them in there. I hope I can. Control clicking, it doesn't work. God bless America. Is it faster to use PuTTY? I got to go to PuTTY anyway, so I'm going to go to PuTTY.
Find that CPU the fastest.
Yeah, but I still got to compile it using PuTTY, so I may as well. And let's make this bigger so you can see it. Change settings. Bling, 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 and bling. Okay. So you can see I have program 911 here, but I need to copy all those files in there. So I'm going to move program. Anything start with program? Program star. No, program.
Underscore.
Yeah, I didn't want to have to do it all, but yeah, it's going to be program 1. Okay, that moves the Java file, and then I want to move input. All right, now let's do ls program 0911. Oh man, great. ls. Okay, so now I have my Java program. Just clear. Now I've got all the files that I need in there and no files that I don't need, which is what you want. Submit J, right? Success, running with this input file, running with this input file. Do I want to preview? Yes, I do. Source files has this source code, which is fine. Then we have 3 ones, a -1 and 2 ones. Execution gives us this correct value. Then we have 6 ones, and it says the equation has no solution. So now you've seen how to code it, comment it, diagram it, and run it in Submit J. Hopefully this little exercise is helpful. Let's go back to the, here it is. So that finishes this whole thing. And that took us an hour maybe, right? So we did an entire program, which is a 1-star program. These 2-star ones might take you a little bit longer. But any questions on that? All right, we're done.